Hello all. In this session we will see a problem which can be solved using CDF and which applies the property of CDF. The problem goes like this. The CDF has been given to you. The CDF of a continuous random variable capital X is given by the following function. Capital F of X is defined as 0 for the interval x less than 0. It is going to be x square for 0 less than x less than half. The value is 1 minus 3 by 25 times 3 minus x the whole square for half less than x less than 3, and it is going to be 1 for x greater than 3. The problem is to find, question number 1, the PDF, the probability distribution function of our capital X. Number 2, the probability of modulus of X less than or equal to 1 using both CDF as well as PDF. So we have been given a CDF. Question number 1 wants us to find the PDF. We will quickly recollect the property that connects CDF and PDF. CDF is denoted by capital F of X. PDF is denoted by small f of x. How to connect both of them? We know that the derivative of our CDF f dash of x is nothing but our small f of x. That is, differentiate the function capital F of x with respect to x, you will be getting your small f of x. So this is the property which we are going to apply over here to get the value of PDF. So what we have to do over here is differentiate the function capital F of x. So what will be our capital F dash of x will now be our small f of x. So this will give me my PDF. The integration or the differentiation over here happens stage by stage. The function is not a single function, but it takes different values in different regions or different intervals. So when we differentiate, then we will have to do it again in the same range wise or interval wise. So what happens in the interval x less than 0? Differentiation of the first number 0 gives you 0. Secondly, when 0 less than x less than half, what happens? So it is differentiation of x square, which is going to give us 2x. Next, moving on to the third interval, half less than x less than 3. What will be the value for this? This is the differentiation of the quantity 1 minus 3 by 25, 3 minus x the whole square. 1 on differentiation is 0, minus 3 by 25 is a constant, keep it as such. 3 minus x the whole square on differentiation, it is something like x square on differentiation is 2x. So what you will be having over here is 2 times of 3 minus x power 1. Next, this function, a cyclic rule or chain rule, minus x on differentiation gives you minus 1. Hence, the total value of this will be equal to minus into minus will make it as plus. 3 into 2 makes it as 6 by 25 times 3 minus x to the power of 1 in the interval half less than x less than 3. And finally, when we have x to be greater than 3, the value of the function will be 1. 1 on differentiation will make it as 0. Be cautious, children. 1 on differentiation is going to be 0. Don't make it as 1. So we have completed the first subdivision, PDF. So our small f of x has been obtained. Now moving on to the second subdivision. So what we want over here is to find the probability of mod x less than or equal to 1 using both CDF and PDF. Okay, so we will see what is meant by this probability of x less than or equal to 1. When this modulus sign is given, this modulus is 1 which takes both positive values as well as negative values. So this can be expanded of the format less than or equal to 1. So the range of x is between minus and plus of this a. What is our a? Minus 1 less than or equal to x less than or equal to 1. This is what we are going to do using or estimate using both CDF as well as our PDF. Now quickly we will recollect one more property which we have seen for the CDF, which says that for a continuous case, probability of A less than x less than b equal to f of b minus f of a. That is the extreme value minus the interim value. So this is going to be a property which we have seen in our CDF and PDF cases. So properties of our CDF says probability of A less than x less than b is f of b minus f of a. So when I am going to apply this to compute the CDF, how I can replace this as? This is going to be f of 1 minus f of minus 1. So a, this is going to be less than x less than b. So f of b, it will be f of 1 minus f of a, which is f of minus 1. Now let us identify where is this f of 1. 1, which is the range for 1. Now here half less than x less than 3. This is my range for 1, which means 1 lies in this interval. So what will be the value of f of 1? So what I need to do over here is, wherever I have x, I will have to replace it with the quantity 1. So we will be left out with 1 minus 3 by 25 times 3 minus 1 the whole square. So substitute. So what we will have is going to be 1 minus 3 by 25 times 3 minus 1 the whole square. So this is my f of 1. So this gives me 1 minus 3 by 25 times 3 minus 1 is 2. 2 square makes it as 4. So this is going to be 25 minus 4 3s are 12 by 25. 25 minus 12 makes it as 13 by 25. Now f of minus 1. Where does our f of minus 1 lie? Minus 1 is a negative number, so it lies in this region. F of minus 1 lies over here. What is the value taken by f at this position? The value taken is going to be 0. So f of minus 1 is going to be 0. So now this gives me f of minus 1 as 0. So probability of minus 1 less than x less than 1, which is f of 1 minus f of minus 1 will be 13 by 25 minus 0. So that makes it as 13 by 25. Now this process we have completed using CDF, that is our capital F of x. They are asking us to solve the same problem using your PDF, which is your small f of x. How can we define this probability using small f of x? Probability of minus 1 less than x less than 1 is nothing but integral of the function f of x dx between the limit minus 1 to 1. But we know that the function from, now don't confuse yourself with this quantity, what we are estimating is PDF. PDF is over here, small f of x. Don't go back over here and look into the quantities, then you will be handling or landing in a wrong direction. Makes sense that you are applying a PDF to evaluate a PDF. Now what happens over here? You want minus 1 to plus 1 in this range, but it is not a single range, it is a split range. 0 less than half, x less than 0, 0 to half, half to 3, and this is going to be x greater than 3. So what we are going to do over here is, we are going to split this single integral into parts. Minus 1 to 0, 0 to the next value will be half, and from half to the last value which it wants to take is going to be equal to 1. into f of x dx. Now let us substitute the value of f of x for these quantities from -1 to 0. What is our f of x? So in this portion, negative portion, f of x is 0. So substitute it as 0 dx. Second quantity between 0 to half. What happens between 0 to half? 0 to half, the value taken by the function is 2x. So this is going to be 2x dx plus next interval, it's going to be from half to 1. Okay, keep in mind the upper limit we require is only till 1. Okay, but over here we have till 3. So don't go till 3. The requirement is only till 1. So stop with 1. What is the value taken by this function from half to 1? It is 6 by 25 times 3 minus x. 6 by 25 times 3 minus x dx. Now we are ready for the integration. This being 0 vanishes, and now this gives us 2 into x on integration is x square by 2. Between the limit 0 to half, 2 and 2 can be cancelled off, plus 6 by 25 is a constant. 3 on integration is going to be 3x minus x on integration is going to be x square by 2. Between the limits 1 and half. So we move on to the next line. So it is going to be x square to the power of half, x square to the power of half plus 6 by 25 times plus 6 by 25 times 3x minus x square by 2. Between the limits 1 and half, 1 and half. So this gives us half the whole square is 1 by 4. 6 by 25 times 3 into upper limit 1. So 3 minus 1 by 2 minus lower limit x is half. So this is 3 by 2 minus 1 by 2. The whole square is 1 by 4. 4 2s are 8. So it is 1 by 8. So now simplify it. 6 by 25. 3 minus half. 3 2s are 6. 6 minus 1 is 5 by 2 minus 8 is the LCM over here. 4 3s are 12. 12 minus 1 is 11. So this makes it as 1 by 4. 6 by 25 times 8 is the LCM. 4 5 4s are 20. 20 minus 11. So 6 goes 3 times into, and this goes 4 times. So it is 1 by 4 plus 20 minus 11. What will be 20 minus 11? 20 minus 11 will make it as 9 by 25 times of 4. So what is going to be the LCM? 25 times of 4. So multiply by 25. So this is 25 plus this is going to be 3 and a 9. 3 is there in front. This is going to be 9. 9 3s are 27. So this makes it as 52 divided by 25 times of 4. And 4 goes in 52. How many times? 13 times. So the final answer is 13 by 25. Please keep it in mind, dear, whether we are evaluating the property using a CDF or using your PDF, the probability value will never change. The process or the methodology is different, but the final answer which you will be arriving at is going to be always the same. So we can see or verify that we have arrived at the same answer, 13 by 25.